Good afternoon, good evening, everyone. My name is Arinze Ede. I'll be taking you in some topics that appear sometimes difficult in WAEC questions. So I'll try as much as possible to break it down to the simplest ways and help you answer the question to get your maximum mark if you have this. This is a question in one of the years in WAEC. This is a WAEC question. And then we're actually taking the topic trigonometry. We're solving triangles. So we want to get some of the missing sides and angles. So in this question, we are given triangle PQR. And then from the diagram, we could see that the angle at S here, that is angle PSQ is 90 degrees, and also angle PQR is 90 degrees. It's given. Also, another thing that is given is that side PS is 9 cm and side SR is 16 cm. So, and then we have XQ to be given as XCM. So what we have here is XCM. So the question now says you should find the value of X using trigonometric ratio. If you are specific about using trigonometric ratio, you can also solve it using similar triangles, but they want us to use trigonometric ratio to solve it. So how are we going to solve it? So we're going to look at some things from, okay, let's observe something from the triangles. Okay, if we assume that the angle at R from, okay, our solution, let's assume that the value of the angle at R is theta. So similarly, if you look at triangle PQR, that's a right angle triangle. Therefore, the angle at P is the complement of the angle at R. From triangle, right angle triangle, okay, it's actually right angle triangle PQR. The angle at, let the angle at R be equal to theta. So what it means is that the angle at the angle at P will be 90 minus theta because they are complementary angles. So here is 90 minus theta. And that, with that idea, okay, so if you consider triangle PQS, so if you consider from triangle, also triangle PQS is also a right angle triangle. So triangle PQS, if you consider triangle PQS, and the angle at S is the right angle. You know, that's the sum of angles on a straight line. So here is 90, automatically here is also 90. Then, if here is 90 minus theta, these two angles are complementary angles. Therefore, here, just this angle here, the angle at Q will be equal to theta. Since the angle at P is 90 minus theta. So here is theta. So if you observe, the angle at R and the angle at Q in triangle QS are equal. Okay, so we've established a particular fact. Now, with that, we can actually get a ratio that contains X. So look at this. If you look at this, with respect to theta, 9 from triangle PQS, tan theta is the same as 9 over X. So tan theta, that's 9, because 9 is opposite theta, and S is the adjacent to theta. This is the hypotenuse. PQ is the hypotenuse from triangle PQS. And also similarly, from triangle QSR, which is also a right angle triangle. If you look at that, it's also a right angle triangle. The angle here is also theta. So tan theta will be the opposite all over the adjacent. So tan theta will also be x over 16. So let's call this equation 1 and this is equation 2. So if you look at it, tan theta is equal to this and tan theta is equal to this. So equating equation 1 and 2, equating equation 1 and 2, okay, or just say from equation 1 and 2, from equation 1 and equation 2, you can see that 9 over x is equal to x over 16, because tan theta is equal to tan theta, therefore 9 over x is equal to x over 16. Cross multiply. That will give you that x squared is equal to 9 times 16. And 9 times 16 is actually 144. But we don't need to multiply it before taking the square root. So for us to get the value of x, you know what to do. What are you going to do? You're going to take the square root of both sides. Because the opposite of squaring something is the square root. Therefore, x is equal to the square root of 9 times 16. And what is the square root of 9 times 16? When you want to take the square root of a product, you can take them one after the other. So you take the square root of 9 times the square root of 16. So what's the square root of 9? You get 3. The square root of 16 is 4. And that 3 times 4 is 12. Therefore, x is 12. So we've actually gotten the value of x. So we'll solve the first part of the equation, which says find the value of x using trigonometric ratio. So we have actually found the value of x using trigonometric ratio. So let's clean that part and then answer the remaining part. I won't clean the diagram because I need the diagram to solve the second question. So the next question says calculate the angle QRS, which is this angle here. So the angle I call theta. So calculate the angle QRS, which is angle theta. So now, how do we calculate angle QRS? Since we already know that x is, we can get that since tan theta. So from this triangle, so tan theta, which is angle QRS, is, or I will say from triangle QRS, tan theta, which is the angle at R, is equal to x, which is already now 12 over 16. So if you reduce that to the lowest term, 12, if you reduce 12 over 16 to the lowest term, 3 can go here, or 4 can go here, it gives you 3, 4 can go here, it gives you 4. So that will give you that tan theta is equal to 3 over 4. Therefore, if you want to, for us to get theta will take the tan inverse of both sides. Therefore, so that we can get theta. So theta is equal to the tan inverse of 3 over 4. Okay. So the tan inverse of 3 over 4. So what is tan inverse of 3 over 4? Okay. The tan inverse of 3 over 4. Let's get our calculator. I think I have my calculator somewhere. Where is it? Okay. The tan inverse of 3 over 4. Okay, this is it. My calculator will have shift tan of 3 over 4, and that gives you 3 over 4. So the tan inverse of that will give you 36.8 something. But since we are asked to approximate it to the nearest degree, the answer would be 37 degrees to the, actually it's 36.8698975. That's all we have there. But to the nearest degree, we'll give you 37 degrees to the nearest degree. Okay, so that is that. Then the last part is we are asked to find PQ. From PQ, we want to find PQ. So how do we find PQ? We have, if you observe, PQS is a right angle triangle. So this is PQS. So if you look at PQS, let's look at PQS. This is how PQS looks like this, where the angle at S is 90 degrees. So the angle here is 90 degrees. So this is the P, and this is the Q, and here is the S. And then if you observe QS, we've gotten QS to be 12, and then PS to be 9. So we can now get QS. So if you look at QS, we can now get PQ. So if you look at PQ, PQ is the hypotenuse, is the side facing the 90 degrees, so it's the hypotenuse. So, and then using Pythagoras theorem, using Pythagoras theorem, we'll have that. Let's assume that here is say, okay, conventionally here is S, so it's x squared is equal to 9 squared plus 12 squared. We're using Pythagoras theorem. 9 squared is 81, 12 squared is 144. Therefore, x squared will be 225, because 81 plus 144 is 225. So, yeah, so x is now the square root of 225, and the square root of 225 is 15. So s is equal to 15. X, which is PQ. Therefore, can write it here. Therefore, PQ, side PQ, is actually equal to 15 centimeters. So, what we've actually solved is a question in trigonometry. Okay. So what did we do? The first thing they asked us to do is that they asked us to find the value of x, and they gave us specifically the method we are to use. They said using trigonometric ratio. So they have actually guided our mind on what to do. So using trigonometric ratio, I assume that the value of this angle here is theta. So from this right angle triangle, which is right angle triangle PQR, the big right angle triangle, the angle here and the angle here are complementary angles. So if here is theta, automatically here is 90 minus theta. And then if you have this right angle triangle and here is 90 minus theta, here is the complement of it, which is here is theta also. And then also here will be 90 minus theta. So with that, so here is theta and here is theta. So using these two right angle triangles we have here, this right angle triangle PQS and right angle triangle QSR, we're able to form an equation that helps us find S to be 12 centimeters. Then the second part of the question says we should find the angle QRS, which is the angle at R. So remember, we call the angle at R to be theta. So we say tan theta is equal to x, which is the opposite all over the, according to trigonometric ratio, tan is defined as opposite over adjacent. So this is the adjacent, this is the hypotenuse with respect to Q, to respect to right angle triangle QSR. So the opposite all over the adjacent is equal to tan theta. So from there we get theta to be 37 degrees. Now the last question says you should find PQ. So finding PQ, if you observe, PQ is the hypotenuse of the right angle triangle PQS. So we used Pythagoras rule to get the hypotenuse. So what do you think? Which theorems did we use? Okay, I would like you to leave your comments in the comment section. Let's see which theorems we used. And then if you have any personal questions that you find difficult in trigonometry, we're going to leave the question. You can just type which year of the WAEC past question, or IGCSE, or the SAT, or also Olympiad questions, where if you see any trigonometric question you find difficult, I'll make a video of that also. And then if you have any question, you leave your question in the comment section. I've said that before. So, and also I said you should check you should write down the theorems we used in this question, the theorems we used to solve this question. I would like you to look to come look. You'll get more videos in our next more questions in trigonometry, solving triangles. In our next video, we're going to look at questions that have to do with bearing, angle of elevation and depression, and some other complex triangles. So See you in the next class and in our next video. Thank you very much.